Welcome back, everyone, to the Deep Dive.
It's great to be back.
Today, we are diving deep into current affairs.
Specifically for our UPSC aspirants out there.
Yeah, so this is going to be your one-stop shop to make sure you're up to date on everything that happened on March 30th, 2025.
Part one, that is.
Part one, that is right.
We'll be back with more.
So much to cover.
So much to cover.
All right, well, let's just jump right into it then.
Sounds good.
So first up, we have some news from the agricultural sector.
Yeah. The Indian government is establishing a second national gene bank.
Okay, a gene bank.
A gene bank.
Mm-hmm.
And this is actually a big deal because...
Yeah, why is this making headlines right now?
Well, it aligns perfectly with the investing in innovations theme.
Mm-hmm.
That was a big part of the union budget for 2025-26.
Okay, so this is like a priority for the government?
Absolutely, a major priority.
And they're aiming to conserve like a huge collection of crop germplasm, right?
Yeah, they're talking about 10 lakh accessions,
Yeah.
which is a massive amount.
Wow, that's a lot.
It is.
So what's the goal here? What are they trying to achieve with this gene bank?
Well, the ultimate goal is to really bolster India's future food and nutritional security.
Okay, so it's all about safeguarding the future of food.
Exactly.
But I think for some of our listeners, myself included, we might not be totally clear on what a gene bank actually is.
Right. So in the simplest terms, think of a gene bank as a giant library, but instead of books, it's filled with the building blocks of our food crops.
Okay, I'm intrigued.
So we're talking about seeds, pollen plant tissues, all sorts of genetic material that's carefully preserved.
And why is it so important to preserve all of this?
For a couple really big reasons.
Okay, lay them on me.
First, it protects plant species from going extinct, which is increasingly important in our changing world.
Right?
And second, it ensures we have this diverse genetic pool to tap into in the future.
Okay, so like a backup for our crops in case something happens.
Precisely. It's vital for crop breeding, for research, and for maintaining biodiversity, which is key for climate resilience. And you guessed it, food security.
So this is like a long-term investment in a way.
Exactly.
This isn't India's first gene bank, though, right?
No, not at all.
So they've already got some experience with this.
They do.
So tell me about India's first foray into the world of gene banks.
So back in 1996, India established its first national gene bank.
Okay.
And this was under the leadership of the ICAR National Bureau of Plant Genetic Resources, or ICAR NBPGR for short.
That's a mouthful.
It is, and they're based in New Delhi.
Okay.
And get this first gene bank has actually grown to become the second largest in the world.
Wow, second only to...
Second only to this Svalbard Global Seed Vault up in Norway.
Oh, wow. That's the one we always hear about, like buried deep in the Arctic.
That's the one, a global backup plan.
That's incredible.
It is, and India's right up there with them.
So how big is India's collection then?
So currently they have a whopping 471,561 accessions representing 2,157 different plant species.
That's a lot of diversity.
It's an incredible collection.
So who gets to actually use all these saved seeds and genetic material?
Well, the great thing is that these resources are available to both public and private sector organizations that are working on crop improvement and conservation.
So it's a collaborative effort.
Exactly.
You mentioned the ICAR NB PGR earlier.
I did.
Can you unpack what they do a bit more for us?
Yeah, so the National Bureau of Plant Genetic Resources, or NBPGR as it's often called,
NB PGR
is essentially the top dog when it comes to managing and protecting India's plant genetic resources.
Makes sense.
They're a part of the Indian Council of Agricultural Research, or ICAR.
Okay, ICAR.
Yeah, and their main job is to make sure these resources are conserved, evaluated properly, and used sustainably for agriculture.
It's like a pretty important role.
Absolutely crucial.
And where are they based?
They're also headquartered in New Delhi.
Okay, so a lot of this is centralized in New Delhi.
Seems like it.
Okay, now I also came across something called the National Gene Fund while I was prepping for this.
Ah, yes, the National Gene Fund.
Can you shed some light on what that's all about?
Yeah, so the National Gene Fund was set up based on the Protection of Plant Varieties and Farmers' Rights Act of 2001,
Okay.
often shortened to PPVFR Act.
PPVFR Act. Got it.
And this fund has a few really key objectives.
Okay.
Number one, it makes sure that any benefits coming from the use of these genetic resources are shared fairly.
So it's about equity, essentially.
Exactly.
Like, what else?
It also directly supports conservation efforts.
Okay, so it's not just about storing seeds, it's about actively protecting them.
Exactly,
Right.
and it encourages sustainable farming practices.
Okay, so promoting good environmental stewardship as well.
Absolutely.
Like, oh, no.
Yeah, last but definitely not least, it provides financial incentives to farmers and institutions who are actively involved in conservation.
So rewarding those who are protecting biodiversity.
Exactly.
Okay, so for our UPSC folks listening in, what are the key takeaways from this whole gene bank development?
So this is really a multi-layered development that touches on a lot of important themes.
Okay, break it down for us.
So first, it shows that India is serious about food security, and it's putting its money where its mouth is by investing in research infrastructure.
Right.
Second, it highlights the critical role of biodiversity conservation and how that ties directly into the larger picture of food security.
Yeah.
And lastly, it connects back to some crucial government policies and legislation like that PPVFR Act we talked about.
So this one news item really covers a lot of ground.
It really does.
All right, well, let's shift gears a little bit and talk about some news regarding the Teesta River.
Okay, the Teesta River.
Yeah, so apparently Bangladesh is open to China getting involved in a big project to manage and restore the river.
Interesting. And this is significant because
The Teesta is a major river for both India and Bangladesh, right?
it's a transboundary river,
Yeah.
a lifeline for both countries.
So any changes to how it's managed are going to have ripple effects for sure.
Definitely.
Okay, so just for context, can you give us a little geography lesson on the Teesta?
Absolutely. So the Teesta River starts its journey high up in the Himalayas. Specifically, it originates from Solama Lake.
So Lama Lake?
Yeah, it's in North Sikkim, India.
Okay.
And that's at a pretty high elevation, around 5,280 meters.
Wow, that's high.
It is.
And it's not just the lake that feeds the Teesta, right?
Right. There are several glaciers that contribute to its flow as well.
Okay, such as?
We've got the Pahunri Glacier, the Kangxi Glacier, and another lake called Cholama Lake, all adding to its waters.
Wow, so it's starting off strong.
Definitely.
All right, so from there, where does the river flow?
So from its source, it heads south, flowing through the Sikkim Himalayas.
Okay,
It passes through key locations like Rangpo in Sikkim.
okay,
Then it continues on through West Bengal.
okay.
And finally, it crosses the border into Bangladesh.
So it's quite a journey.
It is. And in Bangladesh, it eventually joins up with the mighty Brahmaputra River.
Or as it's known in Bangladesh.
The Jamuna.
The Jamuna, right?
Yeah.
Now here's a fun fact for you.
I love fun facts.
Historically, the Teesta was actually a tributary of the Ganges River. Yeah, so at some point its course must have shifted.
Fascinating how rivers can change over time.
They really do.
So how long is the Teesta and how big is its drainage basin?
Well, in total, the Teesta stretches for about 414 kilometers.
Okay.
And its basin covers a substantial area, roughly 12,540 square kilometers.
Okay, and how is that divided between India and Bangladesh?
So the majority of the basin, about 83%, actually falls within India.
Okay.
And the remaining 17% is in Bangladesh.
Got it.
Now, I'm sure the Teesta has its fair share of tributaries as well.
Oh, definitely. Rivers are rarely solo acts.
So which ones are the most notable?
Well, on the left bank, you have some major ones like the Lachongchu, Chakunchu, Dikchu, Ranikola, and Rangpo-chu.
Okay.
And flowing in from the right bank, you have the Zimuchu, Rangyangchu, and the significant Rangjit River.
Okay, so quite a network of waterways feeding into the Teesta.
Absolutely.
Now, rivers are often prime locations for development projects, especially for power generation and irrigation.
Yeah, they're essential resources.
So what sorts of projects are we seeing on the Teesta in both India and Bangladesh?
Well, in India, there are a number of hydroelectric power projects, particularly in Sikkim and West Bengal.
Okay, give us some examples.
So there's the Teesta V Dam, which has a capacity of 510 milliW and is located in the Gangtok district of Sikkim.
Yep.
And then there's the even larger Teesta Third Dam with a capacity of 1,200 milliW situated in the Mangan district, also in Sikkim.
Okay, so those are some big power generators.
They are.
What about West Bengal?
West Bengal has the Teesta Low Dam, the third and fourth projects, generating 132 milliW and 160 milliWs respectively.
Okay.
Both of those are in the Kalimpong district.
Got it.
And then there's the Gajal Doba Barrage, which is primarily used for irrigation purposes.
Okay.
And on the Bangladeshi side, they have the Dwani Barrage and the Barkada Teesta Barrage, both mainly for irrigation.
So lots of infrastructure built around this river.
It's a vital resource.
Okay, so for our UPSC listeners tuning in, what should they be paying attention to with this news about China's potential involvement in the Teesta?
Well, this brings up a few crucial points that are directly relevant to your exam prep.
Okay, hit us with the key takeaways.
First and foremost, this highlights the long-standing and sometimes tricky issue of transboundary water disputes between India and Bangladesh.
Right, because they have to share this vital resource.
Exactly, and the Teesta has been a focal point of these discussions for years.
So understanding the nuances of that relationship and the challenges of water sharing is crucial.
Absolutely.
What else?
It's also important to have a solid grasp of the river system itself.
So the Tista's origin, its course, the major tributaries where the dams and barrages are located.
All of that.
Got it.
And finally, the potential entry of China into this equation adds a whole new dimension.
Right. Suddenly it's not just a bilateral issue.
Exactly. It becomes a question of regional geopolitics with China's growing influence in South Asia.
So understanding the geopolitical dynamics at play is essential.
Absolutely.
All right, well, let's move on to our next topic, which brings us to a different kind of natural event. A significant earthquake recently hit Myanmar.
That's right. A powerful earthquake struck central Myanmar on March 29th, 2025.
And
It was a 7.7 magnitude quake.
wow, that's strong.
Very strong. It caused a lot of damage in Mandalay, and unfortunately there are reports of casualties as well.
That's terrible.
It is.
Now, I know we've covered earthquakes before, but it's always good to refresh our memories.
Absolutely.
So can we take a minute to revisit some of the basic earthquake terminology?
Sure thing.
Like, what are some of those key terms we should all know?
Okay, well, first off, we have the earthquake itself, which is basically a sudden jolt of energy released from the Earth's crust.
Okay, and that creates
Seismic waves.
seismic waves, right, which is what causes the ground to shake.
Exactly.
Okay, now where does that energy release actually happen?
So the point where the earthquake originates beneath the Earth's surface is called the focus.
Okay, the focus.
Yeah, sometimes it's also called the hypocenter.
Okay, got it.
And then you have the epicenter, which is the point on the Earth's surface directly above the focus.
Right, so the epicenter is where you typically feel the strongest shaking.
Exactly.
Okay, and how do scientists actually detect and measure these earthquakes?
They use an instrument called a seismograph.
A seismograph.
Yeah, it basically records the vibrations caused by the earthquake.
Okay, and then there's that term isoseismic line.
Right. An isoseismic line is basically a line you draw on a map that connects all the points that felt the same level of shaking during the earthquake.
So it helps visualize the earthquake's impact.
Exactly.
Now, we often hear about different types of seismic waves.
We do.
What are the main categories and what makes them distinct?
So there are three main types to remember.
Okay.
First, you have primary waves, or P waves for short.
P wave.
These are the speedsters of the seismic world.
Okay.
They travel the fastest, and the cool thing is they can travel through solids, liquids, and gases.
So they can move through anything.
Yep, pretty much.
What about the second type?
So next up you have secondary waves, or S waves.
S waves.
Now these guys are a bit slower than P waves. And importantly, they can only travel through solids.
Ah, so they're a bit more limited.
They are, and they also tend to cause more shaking and therefore more damage.
Oh, so S waves are the ones we really have to watch out for.
Yeah, they can pack a punch.
Okay. And the third type?
And finally, we have surface waves.
Surface waves.
As their name suggests, these waves travel along the Earth's surface.
Okay.
Now, these are the slowest of the bunch,
Okay.
but don't let that fool you. They're the ones responsible for the most destruction.
Oh, wow. So they're slow and steady, but they win the damage race.
You could say that.
Okay, so now that we've covered the basics, let's talk about what actually causes these earthquakes to happen in the first place.
All right, so at the heart of it all is the movement of tectonic plates.
Tectonic plates, right? Those giant slabs of rock that make up the Earth's outer layer.
Exactly, and these plates are constantly shifting and interacting with each other.
Okay.
And as they do, it creates stress along fault zones, which are basically breaks in the Earth's crust.
Like cracks in a plate.
Yeah, you could think of it that way.
Okay. Yeah.
And as this stress builds and builds,
Yeah.
eventually it exceeds the strength of the rocks, and boom, you have an earthquake.
So it's like a sudden release of all that pent-up energy?
Precisely.
Now, there are different types of faults, right?
Yeah, there are three main types of major faults, each associated with a different way those plates are moving.
Okay, so break it down for us.
So first up, you have thrust faults.
Thrust faults.
These happen where plates are colliding head-on at convergent plate boundaries.
Okay.
And those collisions can create a lot of force, which often leads to the most powerful earthquakes.
So thrust faults are the heavy hitters.
You can say that.
Okay, what's the second type?
Next, we have strike-slip faults.
Strike-slip faults.
Now, in this case, the plates are sliding horizontally past each other at transform plate boundaries.
So like rubbing against each other.
Exactly. And good examples of strike-slip faults are the Saging Fault in Myanmar, which is relevant to today's discussion,
Right.
and the infamous San Andreas Fault in California.
Okay, so those can be pretty dangerous too.
Oh yeah, they can definitely cause some serious shaking.
All right, and the third type?
And finally, we have normal faults.
Normal fault.
These occur at divergent plate boundaries where plates are moving apart from each other.
So they're pulling away from each other.
Exactly. And these usually produce less intense earthquakes compared to the other two types.
Okay, so normal faults are the relatively gentler kind.
You could say that.
Now, you've mentioned plate tectonics a few times.
I have. It's a fascinating subject.
It is, and crucial for understanding earthquakes.
Absolutely.
So can you just walk us through how these plate movements actually lead to earthquakes?
Sure thing. So the theory of plate tectonics essentially explains how the Earth's lithosphere, its rigid outer shell, is broken up into these massive plates.
Right.
And these plates are constantly in motion, albeit very slow motion.
Okay.
Now, at convergent plate boundaries, where those plates are crashing into each other, you can have a process called subduction. Yeah, where one plate gets forced underneath the other.
Okay.
And that can trigger some truly massive earthquakes.
Right.
Like the one that caused the devastating 2004 Indian Ocean tsunami.
Right, a megathrust earthquake.
Exactly.
Now, what about divergent boundaries where plates are moving apart?
So at divergent boundaries, you have these things called mid-ocean ridges forming, where new crust is being created.
Okay.
And that process can also cause earthquakes, but they tend to be milder compared to those in convergent boundaries.
Got it.
And then, of course, we have the transform boundaries like we talked about with strike-slip faults, where plates are sliding past each other.
Right, and those can create some pretty powerful earthquakes, too.
Definitely.
Now, the news also mentioned volcanic activity as a potential factor in earthquakes.
Yes, so it's important to remember that volcanoes can also trigger earthquakes.
Okay, how does that work?
So basically, when magma moves around beneath the surface of a volcano,
Okay.
it can cause tremors, and these are called volcanic earthquakes.
So it's the movement of that molten rock that's causing the shaking.
Exactly.
And it's relevant to note that Myanmar does have some active volcanoes.
It does, which definitely contributes to the seismic hazard in the region.
Interesting.
So it's not just plate tectonics at play there.
Now, we've been talking about natural causes, but can human activities also trigger earthquakes?
That's a great question, and the answer is yes.
Really?
Though it's important to emphasize that the vast majority of significant earthquakes are completely natural.
Oh, okay.
There are certain human activities that can induce seismic events.
Okay, give us some examples.
Well, large-scale mining operations can definitely alter the stress patterns in the Earth's crust.
Okay.
Same goes for the building of huge dams.
How?
Well, when you create a large reservoir behind a dam, the weight of all that water can actually put pressure on the surrounding rocks.
Interesting.
And sometimes that can trigger earthquakes.
Wow, so we can actually impact the Earth that much.
We can. And another thing that can cause issues is the deep injection of fluids into the ground.
What do you mean by that?
So this is done in some industrial processes like hydraulic fracturing or fracking, as it's commonly known.
Yeah.
And that can change the pressure underground.
Yeah.
And sometimes that can lead to earthquakes as well.
So it's kind of like we're poking the bear a little bit.
In a way, yeah.
Okay, so focusing on Myanmar, what makes this region so prone to earthquakes?
So Myanmar sits in a really tectonically active zone.
Okay.
It's right at the junction of three major tectonic plates.
Okay, which ones?
You've got the Indian plate, which is pushing northward, the Eurasian plate moving southward, and the Burma microplate, which is moving eastward.
So it's like a three-way collision zone.
Exactly. And all that pushing and grinding creates a lot of stress, and that leads to frequent earthquakes.
Makes sense.
Plus, remember that sagging fault we mentioned earlier?
Right, the strike-slip fault.
That runs right through central Myanmar.
So that adds to the seismic hazard.
Definitely.
Okay, so for our UPSC aspirants, what are the key things to remember about this earthquake in Myanmar in terms of their exam prep?
Okay, so this event is a good reminder to brush up on your seismology and plate tectonics basics.
Okay.
You should be able to explain the different types of faults, the different kinds of plate boundaries, and the earthquakes that are associated with each.
Got it.
And it's not just about global earthquakes. You should also know about the earthquake-prone zones in India.
Right, because India has its fair share of seismic activity.
It does.
So can you give us a quick rundown of those zones?
Sure. So in India, the zones are classified based on the level of seismic hazard.
Okay.
Zone V, which includes the Himalayan region, and the Northeast is considered the most active.
Okay.
Zone 4 covers parts of the Indo-Gangetic Plains and the western coast.
Okay.
Zone 3 covers peninsular India.
Okay.
And Zone 2, which is in the central and southern parts of the peninsula, has the least activity.
Got it. So Zone V is the one to be most cautious of.
Yeah, definitely.
Okay. And finally, how does this all tie into other aspects of the UPSC syllabus?
Well, earthquakes are a major natural disaster. So this topic is directly relevant to disaster management strategies.
Right.
And of course, it's also important for understanding regional geography,
Yeah.
both globally and within India.
Okay, so lots of connections there.
Absolutely.
All right, well, let's move on now to a fascinating development in the health sector.
Okay, what do we have?
There's some news about celiac disease and how artificial intelligence might be able to help diagnose it faster.
Oh, that's interesting. AI is popping up everywhere these days.
It really is, and it's really pushing the boundaries in healthcare, too.
Absolutely.
But before we get into the AI part, can we just back up a bit and explain what celiac disease is for those who might not be familiar?
Sure. So celiac disease is basically an autoimmune disorder.
Autoimmune meaning?
Meaning the body's immune system is mistakenly attacking its own healthy tissues.
Okay.
And in the case of celiac disease, the immune system goes haywire when it encounters gluten.
Gluten.
Yeah, that protein you find in wheat, barley, rye.
Okay, so it's not just a wheat allergy.
Yeah, it's more complex than that.
Okay, so what happens in the body when someone with celiac disease eats something with gluten in it?
So when someone with celiac disease eats gluten, their immune system basically launches an attack on their own small intestine.
The small intestine, why the small intestine?
So the small intestine is where your body absorbs nutrients from food.
Right.
And with celiac disease, this immune response damages the lining of the small intestine.
So it's like the very place where you're trying to take in nutrition is being attacked.
Exactly.
Okay, and that damage to the small intestine lining, why is that such a big deal?
Well, because when that lining is damaged, it can't absorb nutrients as efficiently.
Okay.
And that leads to a condition called malabsorption.
Malabsorption.
Yeah, which basically means your body isn't getting all the vitamins, minerals, and other nutrients it needs.
Wow. So it's like even if you're eating a healthy diet, your body can't properly benefit from it.
That's right.
Okay, so what are some of the signs that someone might have celiac disease?
Well, the symptoms can vary quite a bit from person to person.
Okay.
But some common ones include persistent diarrhea,
Okay.
unexplained fatigue,
Okay.
unintentional weight loss, bloating,
Okay.
and even anemia, which is a lack of red blood cells.
So a pretty wide range of potential issues.
Yeah, it can manifest in different ways.
And if it's left untreated, can it lead to serious complications?
Yes, if it's not managed properly, celiac disease can increase the risk of other health problems down the road.
Okay, so early diagnosis and management is key.
Definitely.
Now, how does celiac disease specifically affect children?
Well, in children, the malabsorption can be particularly problematic because it can interfere with their growth and development.
Right, because their bodies are still growing and need all those nutrients.
Exactly.
Now, is there a genetic component to celiac disease? Are some people more susceptible to it than others?
Absolutely. Genetics play a big role.
Okay.
If you have a first-degree relative, like a parent, sibling, or child with celiac disease, your chances of developing it go up significantly.
So there's a family connection.
Definitely.
And at what age can celiac disease develop?
Well, it can actually develop at any age after a person starts eating gluten.
So it's not just a childhood condition.
Not at all.
So someone could go their whole life without any problems and then suddenly develop it.
It's possible.
Okay. And how common is celiac disease globally?
It's estimated that about 1 in 100 people worldwide have it.
Wow, so it's not that rare.
It's more common than many people realize.
So if there's no cure, how is celiac disease managed?
Currently, the only effective treatment is to follow a strict gluten-free diet for life.
So no bread, no pasta, no cakes.
Essentially, yeah.
That sounds tough.
It can be challenging, but it's the best way to manage the condition.
And it helps those intestines heal, right?
Exactly.
Okay, so for our UPSC listeners, what should they be taking away from this news about celiac disease and AI?
Well, this is a great example of how technology is being used to address health challenges.
Right.
It also highlights the importance of understanding autoimmune disorders and how diet can have a major impact on health.
So lots of relevant themes for the UPSC exam. Okay, well, let's switch gears again and talk about a cool new piece of technology that's being used for environmental conservation.
Okay, I'm always up for cool tech.
Well, this one involves drones.
Even better.
It's called the Silvigard drone.
The Silvigard drone, okay.
Yeah, and it's designed to detect wildfires.
Wow, that's amazing. So it's like an early warning system.
Exactly.
Okay, tell me more.
So the Silvigard drone was developed by a company called Dryad Networks.
Dryad Networks.
Yeah, they're an environmental IoT startup based in Berlin.
IoT, Internet of Things.
Yep, basically connecting devices and collecting data.
Okay.
And this drone is pretty special because it uses AI.
Oh, so it's smart.
It is.
How does it work?
So the Silvigard drone is equipped with sensors that allow it to capture infrared images.
Infrared, so it can see heat signatures.
Exactly, and that's how it can detect fires even in their early stages.
Oh, wow, that's impressive.
And here's the really cool part.
Okay.
This drone works in conjunction with another system called Sylvanet. Yeah, which is also developed by Dryad Networks.
Okay, so what's Sylvanet all about?
So Sylvanet is like a network of ground-based sensors.
Okay.
They're placed throughout a forest, often attached to trees.
So they're out there in the field constantly monitoring.
Exactly.
What kind of sensors are we talking about?
These sensors are designed to detect gases that are released during the smoldering phase of a fire.
So even before they're visible flames.
Yep, they can pick up those early warning signs.
That's incredible.
And the best part is these sensors are solar-powered.
So they're self-sufficient.
They are, and they're connected wirelessly so they can communicate with each other and with the drone.
Okay, so how do the sensors and the drone work together?
So imagine this. A fire starts smoldering deep within a forest.
Okay.
The Sylvanet sensors pick up on those telltale gases, and they send an alert.
Okay.
And that alert triggers the Silvaguard drone to fly to the exact location where the fire was detected.
It was like a rapid response team?
Exactly. Once the drone arrives, it provides real-time information about the fire.
Like what kind of information?
It gives precise GPS coordinates of the fire's location.
Okay.
It sends live video footage so you can actually see what's happening.
Yeah.
And it also provides infrared images which help assess the intensity and spread of the fire.
So it's like having eyes in the sky.
It is, and this combination of real-time data and AI analysis helps firefighters respond more effectively.
Makes sense.
And it can potentially prevent small fires from turning into massive infernos.
So it's about early intervention.
Exactly.
That's really impressive.
It is.
So what are the key takeaways for our UPSC listeners when it comes to this Silvaguard drone and the whole Sylvanet system?
Well, I think this is a great example of how technology and AI are being used to tackle pressing environmental issues.
Right.
It also highlights the importance of early detection and rapid response in disaster management.
Definitely those first few minutes can be crucial.
Absolutely.
Okay, well, let's switch gears again and talk about some news from the Arctic.
Okay.
Specifically Greenland.
Greenland?
Yeah. So U.S. Vice President J.D. Vance recently visited Greenland.
Okay.
And this visit is happening amidst some renewed calls from former President Donald Trump to assert more control over Greenland.
Interesting. So let's break this down.
Let's do it.
First off, for those who need a geography refresher, can you tell us a little bit about where Greenland is and what it's like?
Okay, so Greenland is the world's largest island.
Okay.
It's located in the North Atlantic Ocean, kind of nestled between North America and Europe.
Okay.
The capital is Nuuk, and the highest point is Gumbjørnsfjeld.
Gumbjørnsfjeld.
Yeah, it's a mouthful.
It is.
And climate-wise, we're talking Arctic conditions here.
So pretty extreme.
Definitely winter temperatures can plunge down to like -50 degrees Celsius.
Wow.
And even in summer, the average temperature is only around 10 to 1.